A pleasant morning. So I'm John Romatre from BSc Petri at narito po ako upang representa ang aking reaction paper about sa Chapter 12 Sensor Network Programming. So let's start. Chapter 12 Sensor Network Programming. This is the roadmap of Chapter 12. First is the challenges. Second is the node-centric programming. Third is the macro programming. Fourth is the dynamic reprogramming. And lastly is the sensor network simulators. Wireless Sensor Network. Wireless Sensor Network or WSN is an infrastructureless wireless network that is deployed in a large number of wireless sensors in an ad hoc manner that is used to monitor the system physical or environmental conditions. Next is the levels of WSN programming. First is the node-centric programming approach. Next is the application-centric programming approach. Node-centric programming approach, where is node programmed with the support of sustainable programming language and tools. Next is the application-centric programming approach, which is the part of the network or complete network is considered as a single entity and programmed based on application. Challenges in WSN programming. Challenges in such WSN include high bandwidth demand, high energy consumption, quality of service, provisioning, data processing, and compression techniques, and cross-layer design. The first challenge is reliability. Resilience to change and failures is important in WSNs. Second is the resource constraints, which is the programming environment should allow programmer to exploit energy-saving techniques. Next is the scalability, which is the sensor networks can be very large, programming models must scale, and lastly is the data-centric networks, which is focused on the data, not the device's IC networks. WSN operating system. First is the TinyOS, which is especially designed for sensor nodes those have limited memory, and it has highly documented and widely used OS. Next is the NESC, which is programming language for application development and an extension to C programming language. The NESC has two components, which is module component and configuration component. Module component, which provides application code to implement one or more interfaces. Configuration component, which is wires multiple components in the program and looks after programming control flow. Third is the TinyGals. TinyGals defines components using an interface definition and implementation similar to NESC. TinyGals consists of module composed of components, which is internal variables, external variables, and methods IC. Fourth is the sensor network application construction kit, which consists of configuration language, component and service library, and compiler. And the goal of sensor network application construction kit is to provide smart libraries that can be combined to form WSN applications. Second is to simplify the development process. And lastly is to be efficient. And I learned that the several core components supported of SNAC library are network, MSG Sync, MSG SCRC, timing, storage, and service. Lastly is the thread-based model, which is multiple tasks allowed to make progress in execution without concern that a task may block other tasks or be blocked indefinitely. And it provides developers with a useful abstraction of concurrent execution. Node-centric programming. This the programmer has to translate the global application behavior in terms of local actions of each node and individually program the sensor nodes using the corresponding programming model. Next is the macro programming, which is the group are identified by next context levels, and this is a method using variable data is a special subprogram now called a macro with actual values defined in the main program. This method provides a single master program that can be used many times with different numerical values. Dynamic reprogramming. This is mainly an optimization over plain recursion. Also, these are breaking down of the optimization problem into simpler subproblems and storing the solution to each subproblem so that each subproblem is only solved once. Sensor network simulators. This large scale of sensor networks makes implementation and experimentation difficult and expensive. The sensor network simulators are: first is the Network Simulator NS2, GLOMOSIM, QualNet, Java in Simulators Time or JJST, Scalable Wireless Ad Hoc Network Simulators or SWANS, Objective Modular Network Testbed or OMNET++, TOSSIM, MSTAR, Aurora. At yun lamang po, maraming salamat. At yun lamang po, maraming salamat.